Okay. So last meeting, we have discussed the moment area method, which is one of the method in solving for the slope and deflection of a structure of a beam. This time, we're going to move to the next topic, the conjugate beam method. This is another method in solving for the slope and deflection of beams. Okay, so last meeting I have uploaded your module here, so I hope you have read and internalize the given procedures to solve for the conjugate beam method. Okay, so for the conjugate beam method, the rotation of any section in the real beam is equal to the shear at the corresponding section of the conjugate beam. So if you're looking for the rotation of the real beam in the problem, you're going to solve for the shear in the conjugate beam. That shear in the conjugate beam is now the rotation of your real beam using this method. Okay? So if you want to solve for the rotation of any section on the given beam, in your given beam, you just have to solve for the shear on your conjugate beam. That shear corresponds to the rotation of any section in the real beam. Okay, so kung ano yung section na hinahama po sa real beam, kunin mo lang yung shear doon sa section doon sa conjugate beam. Okay? And for the deflection of any section in the real beam, it is equal to the bending moment at the corresponding section at the conjugate beam. Okay? So if you're looking for the deflection at any section of your given beam, you have to solve for the bending moment on that particular section using the conjugate beam. So what you have solved in the conjugate beam, the bending moment, that will now be your deflection in your real beam. Okay? So we have here for the real beam and for the conjugate beam. So if your type of support in the real beam is a simply end support, and if you have roller and pin, your slope is 0, you have a deflection. Okay? Sorry, your slope is not equal to 0 and your deflection is equal to 0. Wala kayong deflection, meron kayong slope. Okay? So, pagka nag-conjugate beam method kayo, you have to solve for the corresponding shear for the slope and the corresponding moment for the deflection. Since deflection is 0, your moment here is 0. Okay? So if your type of support in your real beam is simply end support, your beam in the conjugate beam is still the same. Simply end support pa rin yung support natin sa conjugate beam. Okay? So if you have a fixed support, you have a slope and deflection equal to 0. Okay? So your shear and bending moment in the conjugate beam is equal to 0. Okay? So if your real beam is a fixed support, your conjugate beam now be a free end. Okay? So pagka meron kayong fixed support, pagka nag-drawing na kayo ng diagram for conjugate beam, your conjugate beam is free end. Okay? And vice versa. If you have a free end for the real beam, your conjugate beam now will be fixed support. Okay? And for the slope and deflection for free end, meron tayong slope and deflection. So you solve for the shear and moment. Okay? If you have now a simply interior So you have a simply interior support. Your conjugate beam now be an internal hinge. Okay? So for interior support, slope, we have a slope there, but our deflection is equal to 0. Okay? So you need to solve for the shear in that internal hinge. And for the moment, this is equal to 0 because we don't have a deflection in interior support. Okay? And if you have an internal hinge for your real beam, your conjugate beam will now be a simply interior support. Okay? So you have to draw your conjugate beam based on your real beam. Okay? And you need to solve for the shear and moment in conjugate beam to solve for the slope and deflection of your real beam. Okay? So we have here an example of drawing a conjugate beam. So if you have a simply supported real beam, yung conjugate beam, the same. Okay? If you have, say, this is A, this is B. Your real beam is a cantilever with fixed support at A. Yung magiging conjugate beam na natin is equal to this diagram. Okay? So your fixed magiging free end. Yung free end magiging fixed. This will now be your diagram for the conjugate beam. Okay? So, internal, yung internal natin magiging hinge. Okay? Yung free end natin magiging fixed. And yung simply end support natin is equal to simply end support pa rin sa conjugate beam. Okay? So, we also have here, fixed magiging free, yung internal magiging internal support, yung roller pa rin siya sa conjugate beam. This is an external support, yung simply end support, kaya roller pa rin siya. Okay? So, if you have a real beam, we have a real beam, ito yung magiging conjugate beam natin. We have here, at the end support, we have a simply end support. So, parehas pa rin sa conjugate beam natin. Okay? Our hinge, magiging roller siya sa conjugate beam. And yung roller natin sa real beam, magiging hinge sa conjugate beam. Okay? And so, forth. So, we have here another example. So, pagka ito, dalawang fix yan, magiging both free end. Okay? So, that's how you draw the conjugate beam, the corresponding conjugate beam of your real beam. This is to solve for shear and moment. Okay? So, if you have solved for the shear and moment of that particular section, yung shear on moment na na-solve niyo in that particular section will now be the slope and deflection of your real beam in that particular section. Okay? So we have here for the procedure for analysis in solving or computing the conjugate beam method. So class, naririnig nyo pa rin ba ako? Clear ba?
Yes, ma'am.
Okay, so no, wala ba kayong sound na naririnig na iba? Kasi,
Wala, ma'am.
okay. Since we are having our Google Meet here, tatlo kami magkakasabay. Okay, so we have here the procedure for analysis. First is to construct the MEI diagram of the given real beam. Okay, so you have to construct the MEI diagram of the real beam subjected to the specified real loading. Okay? So if your beam is subjected to a combination of different load, you can use the MEI diagram by parts, or you can use the relationship of load, shear, and moment in drawing your moment diagram. Kung saan kayo mas comfortable, yun yung gamitin ninyo. Okay? This is to draw for the moment diagram. And after drawing for the moment diagram, you have to construct your MEI diagram. If your flexural rigidity, yung EI natin is constant, syempre, parehas pa rin yung moment diagram natin sa MEI over EI. Parehas pa rin yung diagram natin for MEI. However, if you have a non-prismatic beam, so magkakaiba yung moment inertia natin, syempre, mag-iiba yung diagram ng moment saka yung M over EI diagram. Okay? So after drawing for the MEI diagram of the real, so yung real loading, okay? Yung kukunin ninyong MEI diagram is yung given real beam, specified by the real loading, hindi yung sa conjugate, okay? So after drawing for the MEI diagram, you have to determine now the conjugate beam corresponding to the given real beam, okay? So, kanina na-discuss natin how to draw for the corresponding conjugate beam of given real beam. Okay? So, i-drawing nyo yan. Wala pang load. Huwag nyo pang lagyan ng load. Okay? The supports lang, tapos pagka may hinge, roller, internal roller, yun lang yung gawin ninyo. Okay? So, you have to determine the corresponding conjugate beam of the real beam. Okay? So, after you have determined the conjugate beam, you have now to apply yung MEI diagram. M over EI ito. You have now to apply your MEI diagram as the load on the conjugate beam. Okay? So yung magiging load na ninyo sa conjugate beam is yung na-solve ninyong MEI diagram ng real beam. Okay? So yung na-solve ninyo dito sa part 1, yun yung magiging load ninyo sa conjugate beam ninyo. Okay? So, the positive ordinates of the MEI diagram are applied as upward loads. So, pagka-positive, para consistent tayo, upward load tayo. Pag ganun, pagka meron tayong beam, tapos meron tayong, sa example, meron tayong yan, positive, upward yung load natin. Ganyan. And if you have a negative, meron kayong negative, downward naman yung loading natin. Okay? Pagka nilagay nyo yung MEI diagram dito sa conjugate beam. Okay? For us to have a consistent direction of loading dito sa conjugate beam. Okay, ulitin ko. Pag positive ordinates yung MEI, pag positive, yung applied load natin is upward. Okay? Upward. And vice versa. Pagka downward, pagka negative, yung ating MEI diagram, downward yung magiging load natin. Okay? So that's the third step. So after having the MEI diagram as load of your conjugate beam, you have now to calculate the reaction at supports of the conjugate beam. Okay? So dyan pa lang, yan na, mag-start na kayo mag-solve ng reaction at supports of the conjugate beam. Conjugate beam, hindi real beam conjugate beam. Okay? So this is by applying the equation of equilibrium and condition. Okay? So supports or reaction at supports or moment if you have any. Okay? And then for the next step, after solving for the reaction, you have now to determine the shear at those points on the conjugate beam where slopes are decided on the real beam. Okay? Or determine the bending moments at those points on the conjugate beam where deflection are desired on the real beam. Okay? So after you have solved now your reaction, ang isosolve na ninyo next is the shear and moment at that point kung saan yung kukunin ninyong deflection or slope. Okay? So for example, you want to solve for the slope and deflection at B. Okay? So, in your conjugate beam, you need to solve for the shear and bending moment at that particular point B. Okay? So, pagka ang hinahanap sa problem is the slope and deflection at A, you need to solve for the shear and moment at A for the conjugate beam. Okay? Since yung shear sa conjugate beam, equal siya sa slope sa real beam. Tapos yung moment sa conjugate beam, equal siya sa deflection doon sa ating real beam. Okay? So we have here the shear and bending moment in conjugate beams are considered to be positive or negative in accordance with the beam sign convention. So you need to follow your beam convention. Okay? So pagka positive, pataas. Okay? Pagka negative, pababa. This is depending on your beam sign convention. Okay? So, since pataas tayo ng positive, positive pataas tayo. Okay? For the shear, syempre yung moment clockwise or counterclockwise. Okay? So, pagka positive, pagka ganito yung assume ninyo, positive, negative, counter, clockwise. Clockwise. Remember, we have pagka ganyan. Diba? Pag ganyan. Magaganon yung deflection niya. That is a negative moment. Diba? Tapos pagka ganyan, positive yung moment. So we have here negative moment here, negative moment here, positive moment, positive moment. I hope you remember this. Diba? Ganyan. Pagka-end. Okay? So we need to follow the sign convention. Okay? So we have here for the number 6. So the slope at the point of the real beam, yun yung sinasabi ko. So the slope at the point of the real beam is equal to the shear at that point of the conjugate beam. Okay? So yun yung sinasabi ko na yung shear sa conjugate beam equal siya sa slope ng real beam. Okay? And for the deflection, the deflection at the point of the real beam is equal to the bending moment of the conjugate beam. Okay? So for us to have a uniform sign convention, we have here, pagka-positive yung shear ninyo, yung magiging slope natin sa real beam, syempre pagka-positive yung na-solve ninyong numerical value, ang magiging direction natin, pagkapunta natin sa real beam is equal to counterclockwise. Counterclockwise yung magiging slope natin. Okay? Pagka-positive yung shear. Pagka-negative, ang magiging slope natin is vice versa, clockwise. Okay? So, for example, ito A. So, pagka nakuha natin yan, positive ang lumabas. Pagka-positive ang lumabas na shear natin, counterclockwise. So, pag ganun yung slope natin, counterclockwise daw yung slope. Okay? So, pagka negative naman, clockwise yung slope. Pag ganun yung slope natin. Okay? And for the deflection, pagka-positive yung value natin for the moment, denotes a positive, ang deflection natin upward. Okay? So, pagka ito yung beam natin, ang magiging deflection natin upward. Pagka-positive yung nakuha nating value. Pagka-negative, for example, ganyan yung magiging deflection natin pagka meron tayong ganyan. Yan yung magiging deflection natin upward. Okay? So, pagka meron naman tayong negative bending moment, our deflection is downward. Okay? So, andyan yung deflection natin. Ito yung elastic curve natin. Yan yung deflection natin downward. Okay? For us to have a uniform, you have to remember our direction for bending moment and for the shear. Equivalent niya doon sa may real beam natin. Okay? So, ito lang yung procedure for the analysis of the conjugate beam method. Okay? So, for us to understand further the conjugate beam method, let's have an example. Okay? So, we have here an example. So, kindly read Mr. Okay, kindly read, Mr. Balbin. Are you there? Okay, so kindly read the example.
Using conjugate beam method, the deflection and rotation at free end of the beam shown, EI is equal to constant.
Okay, so we have to solve for the deflection and rotation at free end of the beam shown using conjugate beam method. So we have here a cantilever beam. Meron tayong thick sa A, free end sa B. So yung hinahanap natin is the deflection and rotation here at B. Okay? Ito yung hinahanap natin, yung deflection and rotation at free end. So yung free end natin is at B. So we have here EI is equal to constant. So EI niyan lahat, yung I niya pare-parehas from A to B. Okay? So ano yung sabi sa first procedure? Ano yung first procedure natin? We have to draw for the MEI diagram. Okay? So let's draw for the MEI diagram of this real beam. Ito yung real beam natin. Okay? So this is now our real beam. Okay? So we need to draw for the MEI diagram of our real beam. Okay? So using conjugate moment diagram by parts. Mag-moment center tayo sa B. Okay? So we need to solve for the reaction at A and for the moment at A. So kindly solve for the reaction at A and for the moment at A. So kindly solve. So what will be now our RA? RA?
Ma'am, 90.
So we have 90 kilonewton. Okay? Our MA, what will be now our moment at A? So we have 1/2 times 60 times 3 times the moment center. We have 1.5 and 2, 3.5. So ilan yun?
315, ma'am.
So we have 315 kilonewton meter. Okay? So drawing our moment diagram by parts. So let's draw our moment diagram by parts. Moment center at D. So paano yung drawing natin dito? So we have RA 90. Times 4.5, ilan yon? This is 405 MEI. Since our EI is constant, diretso na nating MEI. This is EI. Okay? So we have 315. 315. We have here the moment 315 over EI. And lastly, we have the load, triangular load. So first, second degree, magkakaroon tayo ng third degree here. So ilan yung value natin dito? This is a third degree curve. So ilan yung magiging value natin dito?
90.
So we have 90 over EI. Okay? So ito na yung magiging MEI diagram natin. Okay? So ano yung susunod na step natin after drawing for the MEI? We have to determine the conjugate beam corresponding to the real beam. So paano natin i-drawing yung conjugate beam natin? So we have here the conjugate beam. Okay? So we have here the conjugate beam. So, ano yung magiging conjugate beam natin pagka ang real beam natin is fixed? Pagka fixed. Ano yung magiging, ano natin, pagka fixed? My 40-minute time out. Okay. So, for the conjugate beam, we have a fix. So, ano yung magiging conjugate beam natin pagka-fix? Free. Diba? Free end. And then, pagka mayroon tayong free end, ano yung magiging conjugate beam natin? Meron tayong fix dito sa may B. This is B, this is A, and this is C. Okay? So, ano na yung magiging load natin dito sa ating conjugate beam? Ano yung magiging load natin? Yung magiging load natin sa conjugate beam is equal to this MEI diagram of the real beam. So, ilagay lang natin dito. That is 405 over EI. Pataas tayo. Okay. We have 315 over EI. Pababa tayo. So, para magkaroon lang tayo ng and we have 90 over EI. Pababa tayo. Okay? So, ganyan na yung magiging conjugate beam natin. This is fixed. Okay? So, this is fixed. Okay. So, our problem is we have to determine the deflection. Pagka deflection yung hinahanap natin, anong kailangan nating kunin sa conjugate beam? We need to solve for the moment, bending moment of the conjugate beam. Pagka rotation ang hinahanap natin, anong kailangan nating isolve sa conjugate beam? We need to solve for the shear. Okay? So we need to solve for the moment here at B and our reaction here at B. Shear. Okay? So the moment at B now is equal to the moment is equal to the deflection at B. Okay, and for the shear or the RB shear, the shear at B is now equal to the rotation of B. Okay, so we can solve for the shear and moment here, diba? You have to take moment at B to solve for the MB, and you have to take summation forces to solve for the shear at B. Okay? So, kindly solve for the shear and rotation at B. Kindly solve for the shear at B and MB. So, I will be back. So, kindly solve first the rotation and deflection at B by solving for the shear and moment of B in our value of rotation and deflection. Simplify our answer. Let's take the summation weights of loadings. Okay? So for this part of our diagram, say this is our 1, this rectangular part, and our third degree is W3. So to simplify our solution, so let's solve for W1, 2, and 3. So for W1, we have here the area of this triangle. We have 1/2 405 over EI times, so we have 4.5. So solving for W1, we have kindly solve this value. And for W2, we have 315 multiplied by 4.5, right? We have a length of 4.5. And for W3, we have a third-degree curve. So to solve for the third-degree curve, we have 90 times 1/3. Wait, nakalimutan natin yung 1/3. So we have 1/3 times 90 times the distance. What would be our distance here? This is 3 meters. Kindly solve this value. Is this correct? The area of the third degree pala ito, hindi second degree. So third degree, so for the area is 1 over n plus 1. Our n is 3. So this is 1/4 for the area. So kindly solve this value. So ano yung W1 natin? Ano yung value natin ng W1?
911.25.
So ilan?
911.25, ma'am.
So 911.25 over EI kilonewton meter square. So remember, this is kilonewton meter multiplied by the distance meter, kilonewton meter square. So for W2, ilan tong value natin dito? So we have 1417.5 over EI kilonewton meter square. Okay? And for the W3. So remember, yung pag-solve ng curve ng third degree, second degree for the area, this is 1 over n plus 1. So yung n natin is the degree of curve. Pagka second degree yan, magiging 1/3 90 times 3. Okay? That is for area. Pagka yung location ng centroid, 1 over n plus 2. Okay? So yung n, that is the degree of curve. So 1/4 of 90 times 3, ilan to?
67.5.
So we have 67.5 kilonewton meters squared over EI. Okay? So madali na lang natin kunin yung shear B at moment at B. Okay? So to solve for the shear B, that is the rotation at B, let's take our summation forces vertical. So assuming upward positive. Okay? So, ang upward natin, W1. Ang downward natin, W2 and W3. Okay? So, na-solve natin yung W1, W2, W3. So, you just have to substitute here. So, summation forces vertical is equal to 0, upward positive. So, we have W1 minus W2 minus W3 is equal to 0. Okay? Is equal to VB, sorry. VB is equal to. So, yan yung hinahanap natin. Shear at B, slope at B. So, W1 is 911.25 over EI minus our W2. We have 1417.5 over EI minus we have 67.5 over EI. So, our VB now is equal to, anong value natin ng VB?
Negative 573.75, ma'am.
Negative 573.75. Correct? 75. Okay? So, that would now be our slope at B. Yan yung isang hinahanap natin. Okay? So, negative means, so ano na yung magiging direction natin for slope? Negative means our slope is
Downward.
clockwise. Slope. So, pagka slope, clockwise, counterclockwise. Okay? Pagka positive, negative yung shear. Pagka moment, pagka positive, di ba? Upward and downward. Okay? Pagka slope yung pinag-uusapan natin, that is the direction is clockwise or counterclockwise. Okay? So, for negative, our direction for theta B is clockwise. Since sabi natin, ang positive natin is counterclockwise. Okay? This is for the rotation at B. So, how about for the moment at B? Okay? So, our moment at B now is equal to, of our conjugate ito, ang pinag-uusapan natin is the conjugate beam. Okay? So, ang moment at B natin for the conjugate beam is equal to the deflection of B in our real beam. Okay? So, how to get for the moment at B? So, we have to take summation at B in conjugate. So, lagyan na lang natin ng prime to differentiate conjugate from the real. So, pagka may prime, that is conjugate. Okay? So, paano na to? So, yung MB prime natin is equal to, we have W1, anong distance natin dito? This is, ano natin dito? So, W1, we have 911.25 over EI times 1/3 of 4.5. Ilan yon? 1/3 of 4.5, that is, isulat ko na lang, 1/3 of 4.5. Clockwise yon, kaya positive. And then we have W2, negative, counterclockwise siya. W2, we have 1417.5 over EI times the distance of the centroid from B, that is 4.5 over 2. Okay, minus, we have 67.5 over EI times what would be now our distance, location distance. So, dito, ilan yan? We have, ilan ito? We have 3 degree ito, so 1/5, di ba?
1/5.
So, ulitin ko, pag location of the centroid for a curve, 1 over n plus 2. So, third degree, 3 plus 2. So, magiging 1/5. Pagka area, 1 over n plus 1. Kaya 1/4 ito. Okay? So, we have 1/5 times, ilan yung distance natin? We have 3. Okay? So, kindly solve for our MB prime. Kindly solve for our MB prime. What will be now our value here?
Negative 1,863 kilonewton meter cube.
Okay, so we have kilonewton meter cube over EI. So this is now the moment at B of our conjugate beam is equal to the deflection at B in our real beam. And negative means our deflection is downward. Okay? So this will be now our answer for the problem. The slope at B is equal to 573.75 over EI and the deflection at B is equal to 1863 over EI. Okay, so the negative and positive will denote our direction in our slope and deflection. Okay? So any question sa problem 1? Problem 1. So ganito tayo ha, for us to have common direction. So anuhin natin yung sir?
Yung negative ni mga lumiwan, negative quantitative survey into the irrigation engineering.
One. Yung
Mga lumiwan
Ma'am Lumiwan. Amin na 3rd year and 4th year, right?
Lagi na.
One, si Ma'am Lumiwan.
Tingnan mo na. Tingnan mo yung pag second year. Static rigid balance. Naman.
Ito naman lang. Okay, let's go back. Any question for problem 1? Wala? Okay, so let's move. Okay, so we have here problem number 2. So a beam is shown below. We have to use conjugate beam method to solve for the following. We have to solve for the rotation at A and for the deflection at C. Okay? So first step, we need to solve for the MEI diagram of our real beam. So this is now our real beam. So this is our real beam. So to solve for the MEI diagram of our real beam, we need to solve first for our reaction of real beam. So kindly solve for the reaction of real beam. So reaction at B. Kindly solve for the reaction at B and reaction at A. So we have 4.533 and 4.5.
70.5 reaction at beam.
70.5 reaction at B and reaction at A. Summation forces.
$64.5.
We have 64.5 kilonewton. Okay. So let's draw our diagram using the relationship of load, shear, and moment. So pataas na 64. We have 64.5. Then minus 15. Ilan pag minus 15? 64.5 minus 15. Ilan ito? So it's 64.5 minus 15. That is 49.5. Okay?
9.5.
So 49.5 minus 90 is equal to negative 40. So we have negative 40.5. Negative 40.5 minus 30, that is equal to negative 70.5. Okay? So this is our shear. So for our moment diagram. Moment. Okay, so the area here is 64 times 4, 64.5 times 4.5. That is equal to 290. 290.25 plus the area here, that is 49.5 times 3. We have 438.75. Okay, minus the area here, so we have 40.5 times 3. This is equal to 317.25. Lastly, the area here, 70.5 times 4.5 is equal to 0. So this will be now our moment diagram. Pero ang kinukuha natin is the MEI diagram. Okay? Pagka prismatic yung beam natin, if our flexural rigidity is constant throughout A hanggang sa B, pwedeng yung M is equal to the MEI. However, pagka tinitignan natin yung given na beam natin, magkakaiba yung moment of inertia. From A to C, we have 2I. From C to D, we have 3I. And from D to B, we have I. Okay? So we need to draw our MEI diagram. So wait lang. So just copy this. Okay. So for our MEI diagram, we need to divide. So from our given 2I, 3I, and I. So we have 2I here, 3I here, and we have I. Okay? So for the first, sa B. Okay. This is A, B, C, D, E. Ganun ba yun? D, and E. Okay. So at C, so at A, 0. Okay? So at C, yung value natin na 290.7, ilan ito? 25. Sa right, ang EI niya is 3I. Sa left, we have 2I. So at C, we have two values here. So merong isang 2I over 2I, meron isang over 3I. So kindly solve 290.25 over 2I. (290.25) over 2 EI. Ilan yun? 290.25 divide by 2. We have 145.125. Okay? So we have here 145.125 over EI. Okay? And then the other one, 290.25 divide by 3. So that is 96.75. So we have 96.75 over EI. Dito yan. Okay? Sa may C. Sa may C, 3I lang tayo sa may C. Both left and right. So the same. 438.75 divide by 3. That is equal to 146. So we have 146.25 over EI. Okay? So that is 146 over EI. Okay? So parehas sa E. Okay? So for D, sa left, meron tayong EI. Sa right, meron tayong I. So 317.25 divide by 3, that is 105. So 105, say 105 is here, 105.75 over EI. And we have 317.25 over EI. Okay, 317.25 over 1I is equal to 317.25 over EI. And then 0. Okay? So this would be our MEI diagram. Okay? Since our beam is non-prismatic, magkakaiba yung moment of inertia natin. So our movement diagram is different from our MEI diagram. Okay? So nagets ba kung paano nakuha yung MEI diagram? So you just need to divide the value of I para consistent na tayo na EI. Okay? So, for the conjugate beam, Pagka nag-drawing na tayo ng conjugate beam, our real beam is simply supported, kaya ang magiging conjugate beam natin and support, simply supported din yung conjugate beam natin. Okay? So this is our conjugate beam. This is A, B. Okay? So what will be now our load for our conjugate beam? So our load for our conjugate beam is equal to the MEI diagram. Okay? So we have the MEI diagram. 145, 96, 146, 105. Okay. So we have 146.25 PI. Okay, so this would be now our conjugate beam method. Conjugate beam diagram. This is 145.125 over EI. Okay? CDE. So after drawing for the conjugate beam, makukuha na natin. So ang hinahanap natin is rotation at A. So for the rotation at A, we need to solve for the shear at A in our conjugate beam. Okay? And for the deflection of C, we need to solve for the moment at C in our conjugate beam. Okay? So we need to solve these two for us to determine the rotation at A and deflection at C. Okay? So balik tayo dito. Okay? So pataas yan. So to simplify our solution, we need to cut our section into simple geometric shape. So triangle here. We have a triangle here. Say we have here, cut natin yan, isang triangle ito, isang triangle ito. Okay? The same with here. Pagkakinat nyo yan, isang triangle ito, isang triangle ito. Say this is 1, this is 2, this is 3, this is 4, 5, and 6. So we have 6. 6. Para ma-simplify yung solution natin. Okay? So lakihan ko lang yung aking drawing. A, B, C, D, E. Ganyan. So this is the first triangle. Pataas tayo. Positive, pataas. So this is W1. This is another triangle. Paano yung cutting natin kanina? This is another triangle. This is W2. W3. W4. And W5. W6. Okay? So kindly solve for W1, 2, 3, 4, 5, and 6. So this is 145.125. This is 96.75. This is 146.25. We have 317.25. And we have 105.75. Okay? Solving for W1. The area of W1 triangle, that is 1/2 of 145.125 over EI. So kindly solve this times the distance here is equal to 4.533, 4.5. So we have 4.5 3, 3, 4.5. So we have 4.5. So W2, we have another triangle that is 1/2 of 96.75 over EI times the distance 3. W3, another triangle, 1/2 of 146.25 over EI times distance 3. W4 is equal to 1/2 W4, 1/2 of 146. So this is the same. W3 is equal to W4. Okay, so the same one. The W5 is equal to 1/2 of 105.75 over EI times 3. Okay, and for W6, we have 1/2 of 317.25 over EI times 4.5. So itong triangle na ito. So kindly solve for W1. What is our value for W1? So what is our value here for W1? Oh,
326.531, ma'am.
326.531 over EI. Okay, so don't forget the unit. Actually, yung unit dito lahat is kilonewton meter squared. Lahat yan. Okay? For W2, value
145.125 over EI, ma'am.
125 over EI. W3 is equal to W4 since parehas lang naman sila. Diba? Hanggang 146. What would be our value here?
219.375 over EI, ma'am.
219.375 over EI. For W5,
158.625, ma'am.
158.625 over EI. And for W6, for W6,
475.875 over EI, ma'am.
so 475 point, ilan yun? Point?
Ma'am,
875.
700.
So we have
875.87.
713.80
830. 13.
over E. Over EI. Okay? So that would be now our value for W1, W2, and W3. Okay? So we can now solve for the shear at ano yung sinosolve natin? Shear at A. We can now solve for the shear at A. In our conjugate beam for us to solve for the slope at A in our real beam. Okay? So how to solve for the shear at A? You can take summation moment at B in our conjugate beam. So taking the summation moment at B in our conjugate beam, clockwise positive, masosolve natin yung A. Okay? So meron tayong shear dito, shear sa A. We have shear A. Okay? So let's take summation at B. Shear A times 4.536, 4.59, 15. So we have 15. Total length of 15. So we have VA prime times 15 plus W1. We have 3, 2, 326.531 over EI. Ano yung magiging centroid natin dito? So we have hanggang dito 10.5 plus 1/3 of 4.5. So 10 plus 1/3 of 4.5. Okay? Magmo-moment tayo sa B. Plus W2, we have 145.125 over EI. Our centroid is equal to hanggang dito 7.5 tapos plus 2/3 of 3. Diba? 7.5 plus 2/3 of 3. Okay? So plus W3. So ano yung magiging W3 natin? 219.375 over EI times the centroid location dito hanggang 7.5 plus 1/3 of 3. So we have 7 plus 1/3 of 3. That is for W3. W4 plus 219.375 over EI. Our centroid, that is 4.5 hanggang dito plus 2/3 of 3. Okay? So 4.5 plus 2/3 of 3. For W4 plus W5, we have 158.625 over EI times, ano yung magiging location natin? We have 4.5 plus 1/3 of 3, right? And lastly, W6, 713.813 over EI times the 2/3 of 4.5. Okay? So pagka nag-moment tayo, remember yung area times the centroid distance from the moment center natin. Okay? So kindly solve for the value of our shear at A. This is now equal to our rotation at A. So kindly solve. What would now be our VA prime? Is equal to 0. Ano yung value natin?
Negative 773.437 kilonewton meter squared over EI.
So over EI. This is now our slope at A. So negative means that our slope at A is clockwise. Okay? Ganyan yung slope at A natin. So we have slope at A is equal to negative 773.437. And yung isang kinukuha natin is the deflection at C. So pagka kukunin nyo yung deflection at C, ikat natin yung conjugate beam natin hanggang dito sa may AC. Kunin natin ito since na-solve natin yung reaction at A, which is the shear at A, which is the rotation at A for the real beam. Okay? So ito. Kasi pagka itong right yung kinuha ninyo, isa-solve nyo pa ulit yung value ng shear at B in our conjugate beam. Okay? To solve for the C. Pwede din yun. Pero mas longer solution lang. Since you have to solve first yung shear sa B natin sa conjugate beam. Okay? So we need to take AC dito sa conjugate beam natin. So ito yung conjugate beam natin. Ito yung C natin. Yan yung magiging load natin. This is 145.125. over EI. Okay? So, ang hahanapin natin dito sa C, since deflection yung hinahanap natin, is the moment. Okay? Moment. So, our moment here at C is equal to deflection at C of our real beam. Okay? Conjugate tayo dito. So, na-solve natin yung RA, which is equal to ilan yung VA natin? 773.437. 773.437 over EI. Okay? So, to solve for the MC, we need to take our moment at C. Okay? So, kindly take our moment at C. So, pagka nag-take tayo ng moment at C, so MC prime is equal to 0, clockwise positive. So, counterclockwise ito. Assumption ko counterclockwise. So, we have negative MC prime. This is counterclockwise, minus 773.437 over EI times, yung distance natin is 4.5. So, we have 4.5. Then, yung W1 natin, yung na-solve natin na W1, para hindi na tayo mahirapan, we have 326.531. So, we have 326.531. 326.531. Okay, so we have plus 326.531 times over EI times the location 1/3 of 4.5, that is 1.5. Okay, so 1/3 of 4.5 is equal to 0. So what will be now our value for MC prime? So kindly solve this. Value of MC prime. So value of our MC prime is equal to negative 2990.67 over EI. So kindly check if my calculation is correct. Okay, so negative means our deflection at C is downward. Okay, downward yung deflection natin. Since the moment at C in our conjugate beam is equal to the deflection at C in our real beam. So parehas siya. So this will be now our answer for the deflection at C. Negative means direction downward. Okay? So do you have any question?
Excuse me, ma'am.
Yes.
Ma'am, damagot 1 JBA, di ba, mabirobirok at slow? Apay, di na, apay, agbaling may nayan jay centroid.
Saan?
Ma'am, JBA, ngayon, di ba, slope ti mabirobirok? Ma'am, apay na inayan pa lang ti, centroid?
Ito, VA. VA.
Yes,
Ito ba yung
ma'am.
tinatanong mo? Ito?
Yes, ma'am. Yes, ma'am.
Remember, pagka sinusolve natin, ang tama na ang slope is equal to shear. However, dito sa solution natin, remember na para makuha natin yung shear sa A, kailangan nating mag-moment sa B para makuha natin yung shear sa A. So pagka nag-moment tayo, syempre, i-multiply natin yan sa centroid. Okay? So to solve for the shear at A, kahit slope man yan, kung ang equilibrium equation na ginamit ninyo is summation moment. Remember, summation moment. Summation moment at B is equal to 0. Moment yung ginagawa nating equation dito para ma-solve yung VA. Kaya nagmumultiply tayo ng location dito. Okay? Nagets ba? Magmo-moment tayo dito sa B. Kaya minomultiply natin ng centroid. Okay?
Okay, ma'am. Thank you.
Okay, so any more question?
Ma'am, the figure iji babana, J2I, 3I, kin-I, niya gamit.
Dito. Ito ba yung tinatanong mo?
Ma'am, iji figure,
Saan? Dito, yung MEI diagram natin.
mga figure, ma'am.
Ito.
Ma'am, niya gamit niya dito 2I, 3I, kin-I.
Okay. So, yung moment of inertia natin sa segment AC, iba doon sa moment inertia doon sa segment CD and segment DB. Okay? Since yung beam natin is non-prismatic, hindi always na yung flexural rigidity natin is equal. Okay? So, sa problem na ito, non-prismatic, so hindi constant yung EI natin. Okay? Since magkakaiba yung given na moment inertia in each section. Okay? So, karaniwang kasi na example, yung EI natin is the same from A to B. Diba? Kaya hindi na natin since pinapalitan yung moment diagram natin doon sa MEI diagram natin. However, pagka may non-prismatic beam na given sa problem, yung 2I, iba yung moment of inertia ng AC, iba yung moment of inertia ng CD, iba din yung CB. You need to solve the value corresponding dito sa moment inertia na 2I. Kaya nagdi-divide tayo dito, dinidivide natin para maging common na EI ito. Okay? Corresponding dito sa moment of inertia dito sa per segment. Kaya nagdi-divide tayo ng 2I, 3I, and I. Okay? So, ganyan. Pagka hindi pare-parehas yung moment of inertia nung full span nung beam. The same with the moment, actually, the moment area method, the same sa double integration method. Kailangan yung i-divide kung magkakaiba yung moment of inertia. So, pagka nilabas nyo yung EI, kailangan yung i-divide kung ano yung moment of inertia. Pagka nag-cut kayo dito for the double integration method, sakto dito sa 2I, HC, 2I. So, you need to divide. Pagka over EI, lagyan nyo ng 2EI yan. Okay? So, pagka nag-cut naman kayo dito, pagka double integration over 3I, so, plus the value over 3EI. Pagka andito na kayo sa segment 3D. Okay? So, you need to consider yung value for the moment of inertia pagka hindi magkakaparehas. Okay? Kaya nag-divide tayo. Given yan sa problem. Depende sa problem kung non-prismatic ba or prismatic yung given. Okay? So, nasagot na ba yung tanong mo, Miss? Yung nagtanong?
Yes, ma'am.
Okay. So, any other question?